Hello, my dear students. Welcome back to the lecture. So, in this, we'll try to see how the construction of a culvert is done. Okay, you can see a small kind of a bridge which is created. So, it's a single span bridge, and here the length is less than 6 meters. So, we can consider this as a culvert. Okay, because a small stream is passing by. So, in the surrounding area, these people have a irrigation land. Okay, you can see a lot of plants which they have grown, and there is a what I mean the stream flowing through that. So in order to take care of that, they have created a kind of a structure here where we can consider this as a culvert. So first what I do is I'll teach you this through a presentation, and then we'll see the complete construction of this step by step. Okay. Yeah. So this is how it started. Okay. This is the final picture what I'm putting, and this is how it started. First we had done the excavation. Okay. So once the excavation was done, these are the area where those abutments are going to come later. Okay, so this was the excavation what we had done. So once the excavation got over, we have done the PCC in this area. So the thickness of PCC was 150 mm, and if I ask you to find the PCC quantity, you can do it, right? So it's a very simple calculation which we already understood. I need this length. I need this. I'll take this as a length. So this is my length, this is my breadth, and the thickness I told it is 150. Multiply all the three quantities, you're going to get the PCC quantity for this particular thing. Okay, after that we are going with the help of this line dori, we are going to keep this shuttering plate here, so that this is how it is created. Okay, so through this only what will happen, the wall is going to come later. So you can see how this shuttering has been done. Okay, so the width what we kept was 300 mm. I don't have a drawing for this, but for the next videos and all I'll be showing you through drawing. Okay, yeah, so this was 300 mm, and now we are going to pour the concrete here. Again, you can find the concrete quantity exactly. I know the width, it is 300 mm. So the depth also I'll be knowing the length of this. So if I multiply all the three quantities, I'm going to get the concrete quantity in this area and in this area. Okay, so once that is done, we started with the pouring of a concrete. So you can see the concrete was poured in both the wall, one on this side and one on the other side. Okay, and after that we'll take it out, the de-shuttering will be done. You can see this how the concreting was done. After that the de-shuttering will be done, and then the curing process is going to start. Okay, so once this is done, next what we are supposed to do, we are supposed to put the foundation here. So we went with a raft foundation. So when I say raft foundation, we'll be putting a bottom mesh. So this is my bottom mesh. Then we'll be keeping a chair here. I'll draw a chair. So yeah, we'll be keeping a kind of a chair here, and over that I'm going to keep my uh, top mat. Okay, since it's a raft foundation, we'll be having a bottom mat and also the top mat. Again, the bars will be first placed in the shorter direction. This is my shorter direction, and then the longer direction. Can you take out the bar bending schedule of this? Again, you can do it. It's very simple to take out the bar bending schedule. How shall we do that? I know the overall length. Let us consider the overall length from here to here is 5 meter. I'll take it as 5 meter for our understanding. Okay, and from here to here, let us consider the length to be 10 meter. Okay, I'm taking some rough values for our understanding. So how, and let us say I'm using a 8 diameter bar. I'll write it here. We are using a 10 diameter bar at 150 center to center in both the direction. Okay, and bottom and both, I'll write both bottom and top. Okay, got it? So this is what we are used there. Let us consider. Got it? So can you find the number of bars required? Very simple. If I want to find the number of bar in the shorter direction, that means if I want to find the number of bar in this direction, I'll put it. Yeah. If I want to find the number of bar here, how many bars have come? How shall I do the calculation? The calculation will be first to find the cutting length. Yeah. Yeah. So the cutting length will be, let me write it here. Hmm. Yeah. Hmm. So this is a bar shape what we have. This is a bar shape what we have. Okay. First let me find this one. First, let me find this length. So this length I know. I told you to take this as 5 meter. Now here we'll take out the cover as 50 mm from both the side. From here we'll take out 50 mm. From here we'll take out 50 mm. In 5 meter, 50 50 is 100 meter. So I'll write it here. 5 meter in the sense it is 5000 mm, minus 50 on the left side, minus 50 on the right side, will end up by 4900 mm. So this will be my 4900. Okay, and then this L, whatever we have given, whatever is a depth, no, so from the top cover and bottom cover you are supposed to deduct. So the depth what we had taken was 1 feet, which is 12 inches, that is 300 mm. So again, cover from both the side, this is 300 mm we had taken. Okay, 300 mm, and from top 50 mm minus bottom 50 mm will come out to be how much? 200 mm. So this will be our 200 mm. So this is 200 and this is also 200. Now you got the overall cutting length of the bar, 200 plus 4900 plus 200. Got it? So it comes out to be 5300. Now to find the number of bar, so number of bar equal to longer span. Okay, longer span divide by spacing of shorter divided by spacing, and for that I need to add +1. So number of bar will be, what is longer span? Exactly, longer span I told you to take it as 10 meter, but again when I put the bar I take out a 50 mm cover from here and 50 mm cover from here. So 10 meter is 10,000 mm. 10,000 minus 50 comes out to be 9,500. So 9,500. Okay, I'll divide it by the spacing. Spacing I told you to take it as 150 for both the bottom and top, and for shorter and longer let us consider. So you divide it by 150. So if I do it manually, let me see what is the answer I'm getting. So 9,500, I'm dividing it by 150. So I'm getting 63.33, 60. I'm getting, yeah, 63.33 can be written as 63 only because it is not beyond 0.5. So 63. And since it is spacing what we have got, to get the number of bar, we have to add one extra. So it comes out to be 64 bar. So it comes out to be how much? 64 numbers of a bar. So that means practically, this is our calculation, okay? So practically they have put 64 number of bar along the shorter direction. Now can you find me the total weight of all this bar? Very, very simple. So for total weight will be, total weight, okay? So total weight will be, what is the total cutting length? So total cutting length you have to add it, okay? 4900 plus 200 comes out to be 5000. Let me do that. 4900 plus 200 on the left side plus 200 on the right side, 5300. So I can write it as 5.3 meter. Multiply this by number of bar, I got 64 number of bar, and then I need to multiply this how much? Exactly the unit weight of 10 diameter bar. So for the 10 diameter bar, the unit weight we know it is 0.39, isn't it? How did I get this 0.39? Let me do it here. So what is the weight of a bar? I mean diameter of a bar, it is a 10 square. The formula I'll write first. If you don't remember, all these things I've covered in my earlier course. Only then you come to my advanced course. Okay, divide by 162.5. Okay, got it. So all these are the application of that. That's it. So 10 into 10 is 100. Shall I write this as 10 into 10? And I'll divide it by 162.5. Yeah, yeah. So can you quickly tell me what is the answer you're getting? Will do. So 100 divided by 162.5. Okay, sorry, it is not 0.39. Okay, 0.39, not 0.39. Sorry, it is uh yeah, 0.62. Yeah, exactly, 0.62. Yeah. So finally, you tell me what is the answer you are getting. I'll write it here. I'll write it here. So weight will be, try to do this calculation. 5.3 into number of bar we got 64, and into it is 0.62, right? So I'm getting 210 kg, 210 kg. So this is a small changes we are supposed to do. It is not 0.39, it should be 0.62. Yeah, got it. So this is the final answer we have got. So only for the shorter span I've explained you. You can take it as an assignment and do it for the longer span as well. Okay. So I require 210 kg of steel if I want to put this. Again, you do it for the longer direction. Similarly, you have to multiply this by 2 because we are going to put the bottom mesh and the top mesh. Got it? Great. Yeah, you can see how these people are doing. Okay, actually they should have cleaned all these things. Again, they're doing it in a local construction, so there is no much quality control and all. Okay, not an issue, but you should know all these things. So horizontally they have put this bar, isn't it? Shorter span, then they'll keep the bar along the longer, and this is how it looks. So once that is done, you can see the chairs being placed. So this is a chair what we have, so that you can take care, I mean, so that you can balance the top mesh over that. Okay, so after that, what they have done, you can see the top rebar. This is my top rebar here. So in this way they keep a top rebar. So now you can see, you got an idea. There was a bottom mesh, they kept a chair, and you can see the top mesh also coming over that. See here, this is top mesh, this is horizontal, vertical, and bottom also horizontal and vertical. So now it is a kind of a raft. Yeah, now you got an idea. So this is the entire raft what we have put. So once the entire raft has been put, next what we have done is, next whatever image I took, it is directly at the time of concreting. Again, you have to put two abutments here. So when I say abutment, that means in this portion, here one abutment is going to come here. In this portion, one abutment is going to come. Okay. So that marking will be done and that will be given in the drawing. But I don't have a drawing with me, not an issue. In the drawing they might have written that your abutment should come here, and this will be the width of your abutment, and this is how your abutment should come. Okay, this is a marking what they have given. So what we do, we bring a bar, we cut a bar according to that, and then we'll bring a bar and keep it inside this. We'll give a L to that, otherwise it won't stand, isn't it? One L here, one L on that side. So one L on this side, one L on other side. So in this way what we do, we try to keep the reinforcement for the abutment. Let me do that quickly. Okay, similarly on this side also I'll do it. Yeah, one on this side, one on this side. Alternately we will do, so that it will have proper a kind of anchoring there. Okay. Huh. Got it. So I hope you have understood how we have done it. So once you have understood with this, once you are done with that, next you see here how we have done. You can see the same thing. See, this is what they have done. Okay, it's a abutment reinforcement what we have. So this is how we have done. We have placed it here. You can see the L shape, whatever I explained, see how the L has been given. They brought a bar, and you can see. So again, how much this L should come? It's actually a development length. It will be written in the drawing. Okay. Based on that, we are supposed to do the execution. So this is done. This is done, and then we are going to pour the concrete. Why this chute has been kept? Because again, if you directly pour the concrete, a lot of segregation will happen. So with the help of this inclined chute, we are going to pour the concrete. You can see how the concrete is being done. So in this way, so this was almost in the evening time. Okay, almost everything is done. So almost the last portion is left out. So once we are done, this is also concreting, and finally everything will be done. Okay. So this is a raft what we have created. You got an idea how this is created, and then this is a grass what we have put, because since it's a huge area, uh, you could have put a gunny bag over that and done the curing. But what these people have done, this is a grass what you get. They have put a grass everywhere, and then they have sprinkled water over that. So that what will happen, that water will be absorbed on this grass, and because of that the curing is going to happen there. Okay, got it. So in this way, and then whatever soil we had, like whatever side, this backfilling we have done. Okay, this backfilling we have done it, so that is why it looks like this now, this much area. Got it. So once this is done, next what we are supposed to, exactly, we are supposed to do the casting of this abutment and this abutment. So you can see again the shuttering will be done for this. We'll not cast the abutment at once, because it's difficult, right? We don't do that. So we are going to do it in layers, one or two or three layers we are supposed to do. Again, the shuttering has been done. So in this way, both the sides the shuttering will be done. This is a normal 10 diameter bar what they used it here. Okay, 10 and 12 diameter. This is we are longitudinal. This is your horizontal binder what we are used. And then you're supposed to keep the cover block and all. And then what will happen after that? Once that is done, everything is ready now. This will be a kind of inclined here, because through this only your water is going to flow later. Got it. Then we have done the casting of this. See, this is the first layer casting what we have done. We have taken, we have done the de-shuttering, and we have lifted it again. So this is my second lift. Again in the second lift, again we'll do the concreting. Okay, again we'll do the second layer. You can see this is my second layer. The first was done up to here. This is my second. So once the second is done, everywhere the concreting will be done. And then next what we are supposed to put, next we are supposed to do the this thing. What is that? We have to keep a props, and here itself the slab is going to come. Okay, so this is abutment number 1. This is my abutment number 2. Okay, 2 abutments what I have, and the water is going to flow through this. Got it? Now you got an overall idea how the construction was done. We started from here, we did the excavation, the PCC was put, and then the raft was put, then the abutment. This is abut. Why I'm calling both as abutment? Because this is also end support and this is also end support. Just in case if I had one more here, then this would have been a pier. Okay, got it? Yeah. So then we are going to make this side retaining walls and all, so that when we do the backfilling, no, the soil should not come, and also this will give a smooth movement to the flow of the water. If you don't do that, then what will happen? The water whichever comes, it will go in this direction and all. So in order to have a proper um, way for the water to flow, we create this wing wall here, here, and even in this direction, and even in this direction, all the 4 directions. Okay, so you can see this is how again in the layers we are going to create that. Okay, so here also we created, here also we created that, here also we are creating, here also. So in this way everywhere this wall will be created here and here. This is a wing wall, here also wing wall, here also wing wall. Okay, and then once that is done, next we are supposed to put the reinforcement. Then how do you put? You put this thing. Okay, this is my abutment cap, this is also abutment cap. Over that the props will be kept, and then the reinforcement will be arranged. Again you can see how it has been arranged. You are given a props, and like we do it for the slab, no, we have kept a across span, and over the across span the centering plates are arranged. That is, the shuttering plates are arranged for the centering, and this is how it looks finally. Okay, and once that is done, next what we are supposed to do exactly? Next we are supposed to put the reinforcement. Okay, so again after that, if you do the concreting, this will become your slab. So all the this thing has been done, reinforcement has been tied. So again here the same thing will happen. We have made use of a 25 diameter bar. So right, so in this way we have arranged it. Again we have a bottom mesh and we have top mesh. Bottom you can see horizontal and vertical, we are given a chair, and then again the top portion we have given. So in this way what has happened, everywhere we have done. Again it is a crank. Okay, so I'll show you this in a deck slab when I go for further videos, but right now what you can identify is that it's a kind of a crank what we have given. That means your bar will come from here. Okay, like this, it will bend, it will come, they have got a crank here, and it will go in this direction. Okay, it will go up to here. Similarly on the other direction, you'll bring one more bar from here. Yeah, your bar will come like this. I mean, from here the crank will happen, your bar will come like this, it will get a crank here. Okay, and then it will go here. Got it? Okay, this will be bent in this way, it will be taken down. Got it? So in this way, alternatively we are going to do this alternate crank bar. So in this way everywhere it has been arranged. Okay, yeah. So finally the concreting was done for this. Cover block and everything will be kept, and after that the concreting will be done. So you can see the concreting which has happened here. So this is a concrete what we have put, and once the concreting is done, next what you're supposed to do exactly, you're supposed to do the curing of this. So this guy is creating a bund here so that the water can stay there, and after that we are going to do the curing in this way. These are the pipes what we are going to insert at the time of casting of the slab, because since because there's a movement of vehicle, and when the water falls, I mean during the rainy season when the water comes, I don't want the water to be collected on the slab, it has to pass through, right? So that is why these pipes will be put along with the casting of the concrete slab, and later this portion, this portion, and this portion will be cut so that the water will flow from here, and then it will go into this particular stream. Okay, finally you got an idea. So this was the slab what we created. Then the additional, this is a barrier or a handrail what we have created, so that it is a protective things what we do the casting, so that no one falls down or no accident things are going to happen. It's a simple thing you're supposed to do. You do this concreting, and over that you insert the steel poles and the horizontal poles, and so it will create as a protective measure. And then we have kept, this is called as weep holes. So why it is called as weep holes? Because you have done a lot of backfilling. So again, when I've done a lot of backfilling during the rainy season, there will be water in the moisture, right? So if there is a water in the moisture, it has to pass through, right? If you don't give this weep holes, what will happen? It will create a lot of pressure, and because of that, it will create a pressure on this wall. So I don't want that pressure to be created. So what I do, I give this kind of holes here. So whenever there is a water in the soil, what will happen, that water will pass through this. As a result of that, whatever pressure is created in this area, no, that will be released. If I don't give this, a lot of pressure will be created because of the water which is stored in the soil, and it will put a lot of lateral pressure on this. Again, there may be a chance of the cracks and all. So that is why we give these things. Okay. Now you got an idea how it was completely created. So this is a wing wall what we have created. Okay. And through this, then finally this is how it looks. You got. So the road was created. Before, the road was not there. The road and the bridge, the culvert was sanctioned at once, and the culvert is created. The This thing is also created. The road is also created, and you can see the water flowing, right? So this is how the water flow. So this was created. Why? Because whatever backfilling soil we had done, this was a backfilling soil. If you don't create, the soil will fall here. And also, by doing this, you are giving a proper movement or a proper a way for the water to flow through this. So that is why this particular wing wall will be created, and this is how it looks. The water from this area is going to come, and this is how the movement will happen. You can see that hole here also, right? Yeah, whatever pressure will be created, that will be released. Whatever water will be there, no, so that will be released. And finally, yeah, this is how the entire culvert is going to look. Great. So I hope you have enjoyed my lecture up to here. We got a complete idea like how this entire culvert was constructed. So in the next lecture, I'll show you the complete video for all the construction so that we get few other ideas. We'll see you back in the next lecture. Thank you.